Hey everyone, and welcome to This Explainer. Today we are going to cut right through the massive industry hype surrounding AI agents. We're going to pull back the curtain and uncover the actual mechanics of how they work under the hood. So if you're a focused learner wanting to skip the fluff and get straight to the mechanics, you are absolutely in the right place. Let's kick things off with a pretty fascinating paradox, right? Why are large language models so incredibly smart yet kind of helpless at the exact same time? It's wild. Despite having these massive context windows and incredible reasoning abilities, bare LLMs are fundamentally trapped. Their knowledge is entirely frozen at the time of their training, making them incredibly powerful thinkers, but totally isolated from the outside world.
Think about it. Without real-time data or the ability to actually run code, a bare LLM is basically a brilliant brain trapped in a jar. Looking at this breakdown, you see its impressive reasoning capabilities on one side, but on the flip side, its hard limitations are glaring. Because of this isolation, it literally cannot browse the web, run compute, or check live APIs. And when it's pushed beyond its static limits to answer questions it just doesn't have data for, well, a 2024 study proved that it is mathematically prone to inevitable hallucinations. It just predicts plausible tokens, not verified facts.
To fix this trapped brain problem, we're going to build a layered mental model today. We'll start with the bare LLM problem, then look at function calling, dive into the React agent loop, tackle real-world loop engineering, and finally wrap up with multi-agent orchestration.
Okay, step 1, the bare LLM problem. Let's really look at these capabilities and limits.
Notice the gap between the two extremes we're dealing with. On one hand, traditional deterministic software is absolutely rock solid at exact math and real-time data access, but it's terrible at open language understanding or handling ambiguous goals. On the other hand, the bare LLM is this language genius, but completely drops the ball on exact computation and dynamic tool selection. Agentic AI? It sits perfectly in the middle. It takes the rich language reasoning of the LLM and combines it with the dynamic execution of traditional software to solve complex problems that neither could solve alone.
Moving on to step 2, function calling. Or, as I like to think of it, giving that brain in a jar some actual hands.
Function calling, you might also hear it called tool use, is the core mechanism making this work. But listen, we need to make a critical distinction right out of the gate. The LLM does not execute the code itself. Let me repeat that. It does not run the code. Instead, the LLM outputs a structured description of its intent. Usually that's in a JSON format detailing exactly what tool it wants to use and what arguments to pass. Your host application acts as the hands, actually executing that code on behalf of the LLM.
So how does that actually play out? Well, it's a 6-step protocol. Let's say we're building a shopping agent. First up, the developer registers tools, giving the LLM a schema for things like search_products or get product details. Second, the user asks in chat, show me details about the blue running shirt, which gets sent to the LLM along with those tool schemas. Third, the LLM seamlessly decides it needs more info, so it outputs a JSON intent to call the get product details tool. Fourth, the harness, your host software, actually executes that API call. Step 5, the result is injected back into the conversation context. And finally, step 6, the LLM synthesizes that data into a grounded, natural language answer for the user.
When you map out this entire architecture, pay special attention to the routing and dispatching happening at the bottom. The LLM's probabilistic reasoning handles the what and the why up top, but your deterministic host software, it handles the actual execution down below, whether that's a web search, a database query, or a REST API. This setup guarantees correctness in the action itself.
Okay, part 3, the React agent loop. That stands for reason plus act.
There's this quote I absolutely love from the Agentic engineering guide. It goes, every agent is a loop. Think, act, observe, repeat. The loop itself is trivial. What makes it production grade is how you handle the edges. That hits the nail on the head, right? The crucial takeaway here is that an AI system only becomes truly agentic when it moves past a single-turn chatbot response and enters a continuous, iterative execution loop to actually solve a goal.
This foundational React architecture is driven by a core loop that is deceptively simple. In code, it's often just like 6 lines. First, you have a thought phase, to reason about what to do based on what it knows. Then, an action phase, to select and emit a structured tool call. And finally, an observation phase, where it reads the tool's output appended to its context. It just repeats this think, act, observe cycle iteratively until it hits a decision point where it recognizes, aha, the user's overall task is finally complete.
Which brings us to part 4, real-world loop engineering. Because those 6 lines of code, they need some serious production discipline.
Why? Well, because in the real world, things break, tools fail, APIs timeout. Our agent has to gracefully adapt instead of crashing or spinning into some infinite loop of doom. You absolutely need strategies like retry with exponential backoff for network timeouts or fallback chains to try alternative tools if one is down. You also need circuit breakers to stop calling a completely broken service. I mean, if the weather API goes down, you want your agent to realize it and pivot, not retry itself into a massive cloud computing bill. This dynamic replanning capability ensures the agent can change its strategy when early steps prove impossible.
And then, of course, we have to talk about security. Beware of prompt injections. If your agent can execute actions, malicious users will 100% try to trick it into exposing sensitive data or executing unauthorized commands. It's essentially doing things like SQL injection, but by using conversational natural language. This means explicit conditional logic, heavily restricting the agent's action space, and robust input sanitization are absolutely mandatory guardrails, no exceptions.
When we look at the full production lifecycle, you'll see we have to balance those strict guardrails on one side with context management on the other. Because as an agent loops 10, 20, or 30 times, its memory can easily overflow. Strategies like sliding windows, where you only keep the last few turns of conversation, or periodic summarization of past steps are essential so the LLM doesn't exhaust its token budget while trying to complete a long-running task.
All right, final section, multi-agent systems. This is how we scale up when things get really complex.
Look, you simply cannot fit a coding expert, a data analyst, and a creative writer all into one single system prompt. The context window just gets way too messy. So, enterprise software uses specialized orchestration patterns. You might use a supervisor pattern where a top-level orchestrator agent delegates isolated tasks to specialized subagents, or maybe a pipeline pattern for sequential, predictable chains of work, or even a fan-out pattern to have multiple agents search different sources simultaneously. The key here is that each specialized sub-agent runs in its own isolated context window, keeping everything incredibly focused and efficient. But what happens if we don't want to hard-code our agent's tools in advance? Enter the Model Context Protocol, or MCP. This is a brilliant open client-server architecture that allows an LLM application to query a server at runtime to dynamically discover what capabilities are available. It frees our agent from fixed toolsets, creating a highly modular and extensible system where an agent can literally adapt to new APIs on the fly without needing a single code rewrite. It's a total game changer.
As we wrap up this explainer, I want to leave you with one fundamental equation. Agentic AI equals LLM reasoning plus function calling plus loop engineering. This represents a massive architectural shift in software development. We are now combining the open-ended natural language capabilities of LLMs with dynamic, real-world execution to solve completely novel problems.
Which leaves us with one final big question. The core reasoning loop of an AI agent is deceptively simple. Like we said, often just 6 lines of code. But are you ready for the engineering around it? While the magic of AI reasoning gets all the hype, it is the rigorous loop engineering, the error handling, the guardrails, the context management that truly makes agentic AI a reliable reality in the real world. Thanks for joining me on this explainer. I hope it gave you a fantastic mental model of how agents actually operate under the hood. Keep learning, and I'll catch you next time.